Here we solve the numerical that is related to chapter AC circuit. So here the numerical that is given that calculate the inductive reactance of 3 millihenry inductor when 60 Hz and 10 kilohertz AC voltage are applied through the inductor. So calculate the inductive reactance in both the frequency 60 Hz and 10 kilohertz. In the B, that find the root mean square current for each frequency if the applied voltage is 120 volt. So here we write at the inductance of the inductor that is equal to 3 millihenry, that is equal to 3 into 10 to the power minus 3 Henry. Frequency F1 that is given, F1 is equal to 60 Hertz. F2 that is given the 10 kilohertz. Kilo that we can write it as 10 to the power 3 Hertz. So F2 we can write it as 1 into 10 to the power 4 Hertz frequency. So we find the inductive reactance XL. So we find the XL at frequency F1 that is 60 Hertz. Value of the inductive reactance that is the 2 pi FL. So here we use the frequency F1 2 pi that is 3.1416. Frequency F1 that is given to 60, L that is given 3 into 10 to the power minus 3. So inductive reactance at frequency F1 we find that is the 1.13 ohm. So here we find the first answer of the inductive reactance at the frequency F1 that is the 60 Hertz. Now we find the inductive reactance at the frequency F2. So here we add frequency F2 that is given that F2 that is equal to 1 into 10 to the power 4 Hertz. So we know that the formula of XL that is equal to 2 pi FL. So here we use the frequency F2. So it becomes F sub 2. Put the values 2 into 3.1416. F2 we write it as 1 into 10 to the power 4 Hertz. L that is given 3 into 10 to the power minus 3 Henry. So value of the inductive reactance at the frequency F2 it is equal to 188 ohm. That is the inductive reactance at frequency F2. Now we find the root mean square current. What is the root mean square current? We know the root mean square current that is denoted by r.m.s is equal to that we find it at each frequency. At each frequency, both frequency we find the root mean square current. If the applied root mean square voltage is this 120 volt. Root mean square voltage that is given the 120 volt. Okay, here we know the formula of the find the frequency at frequency F1 that is equal to 60 Hertz. That is the 60 Hertz. We know the root mean square current formula that is equal to I root mean square. Okay, now we use here the formula of the Ohm law that is equal to V is equal to I. R here we use the resistance of the inductive reactance that is the XL. So here we use the root mean square current value. So we write it I, V r.m.s and I r.m.s. So here we find the I r.m.s. So formula become V r.m.s over XL. So here we use the formula V r.m.s over XL. Okay, here we find the XL at the frequency F1 that is equal to 1.13 ohm. So here we write the XL that is equal to 1.13 ohm. Put it in this formula. So here we know the VRMS that is equal to 120 XL that is the frequency 60 Hz is 1.13 ohm. Okay, here we find the root mean square current at frequency F1 that is equal to 106 ampere. That is the root mean square current. Here we find the B part at frequency F1 and inductive reactance XL. Now we find the at F2 that is equal to 10 kilohertz. That in the F2 we find the inductive reactance that is the XL is equal to 188 ohm. We find the root mean square current by using the formula I r.m.s equal to V r.m.s over XL. So root mean square current value become equal to that is equal to 120 XL. We find that in this frequency 188. So I r.m.s that is equal to 0.637 ampere. So that is the root mean square current at frequency F2. That is all about the numerical that is related to the chapter AC circuit.